Hello everybody, I'm Misbah, your maths educator, and we are over here with the Sutra session wherein we are going to see every formula which is there in grade 10 mathematics. So let's start with the very first chapter, that is real numbers over here. So in real numbers, if you specifically talk about formulae, only one formula is there. Suppose you have got two numbers a and b. So the product of the numbers a and b, that is equal to the product of their LCM and HCF. So the LCM and HCF is the LCM and HCF of these two numbers. So I hope it is clear. And one more thing I would like to add on over here, that if you have got two co-prime numbers, so the product of the two co-prime numbers, the HCF of two co-prime numbers is 1 only. And the LCM of two co-prime numbers, LCM of two co-prime numbers is the product of the numbers itself. If this happens, if A and B, they are co-prime numbers. So if A and B are co-primes, okay, I hope this is clear to you. Now we are going to do the formulae in polynomials. So let's start with it, guys. So basically in polynomials, you talk about quadratic polynomials. So that is the standard form of a quadratic polynomial is ax square plus bx plus c is equal to 0. And obviously a is not equal to 0. Because in a quadratic polynomial, the coefficient of x square can never be equal to 0. So suppose alpha and beta are the zeros of a quadratic polynomial. The sum of the zeros of a quadratic polynomial is equal to minus b by a, where b is the coefficient of x and a is the coefficient of x square. And the product of the zeros is equal to c by a, where c is the constant term over here and a is the coefficient of x square. I hope that is clear to you. Now one more thing is there in polynomial. If suppose the sum of zeros of a quadratic polynomial is given to you. Suppose I am writing it like this s, and the product of the zeros of that quadratic polynomial is p. I am writing capital P. So if somebody asks what is that quadratic polynomial, so that quadratic polynomial will be like this: x square minus sum of the zeros into x plus product of the zeros. Right? Now you will ask, is this the only quadratic polynomial possible? The answer is no. Over here, you can multiply by any real number. So I am taking it as k, and k can be any real number, that is 1, 2, 3, minus 8, minus root 2, anything it can be there, right? Obviously it cannot be 0. It cannot be 0. So that's all about the concepts, the formulae in this chapter. Now we are going to talk about the formulae. You would not say formulae in this case. It is the relationship between the coefficients in case of a pair of linear equations in two variables. So the standard form of a pair of linear equations in two variables is this: a1x plus b1y plus c1 is equal to 0, and a2x plus b2y plus c2 is equal to 0. Right? And over here you write a condition basically that a1 square plus b1 square is not equal to 0. It means that a1 and b1 cannot be simultaneously equal to 0. And over here as well, a2 square plus b2 square is not equal to 0. Okay, so I hope it is clear. Now basically the thing which comes in the examination, which you can call as formulae, is solvability rules, right? That the conditions for one solution, if you have got one solution, so you call it one solution, or geometrically you call it intersecting lines, because their graphs will obviously be straight lines, guys. So the condition for one solution, or unique solution also you call it, it is a1 by a2 is not equal to b1 by b2. Right? Now what is the condition for infinite solutions? Infinite solutions if you have got. And geometrically infinite solutions you write as coincident lines. Coincident lines. So the condition for infinite solutions or coincident lines is A1 by A2 is equal to B1 by B2 is equal to C1 by C2. Okay. Now the third thing is no solution, right? The third thing is no solution. So the condition for no solution, or you will say parallel lines, because there is no common point in case of parallel lines, so no solutions, no solution. So the algebraic condition for no solution is A1 by A2 is equal to B1 by B2 is not equal to C1 by C2. So that is the conditions, these are the conditions over here which you can use. So that's all about formulae if you say in this chapter. Now we are going to see the formulae in the chapter quadratic equations. So the standard form of a quadratic equation is this, guys: ax square plus bx plus c is equal to 0, where obviously the coefficient of x square can never be equal to 0. So the first formula over here is the quadratic formula itself. That is the quadratic formula, which is also called the Sridharacharya's formula, Sridharacharya's rule. Sridharacharya's rule it is also called, right? So the solutions of this quadratic equation using the quadratic formula, they are x is equal to minus b plus minus square root of d upon 2a, where d is equal to b square minus 4ac, correct? And this d is also known as the discriminant. This is known as the discriminant, right? So that is the quadratic formula for you. Now in this chapter quadratic equations, one more thing is there, that is nature of roots. Although this is not a very different formula, but you will use it in questions basically. Nature of roots. So x is equal to minus b plus minus square root of d upon 2a, guys. Okay, so three things are there. If discriminant is greater than 0, then you have got real and distinct roots. You have got real and distinct roots in this case. And the second thing is, if discriminant is less than 0, then you have got no real roots. No real roots. And the third condition is, if discriminant is equal to 0, then you have got real and equal roots. Real and equal roots. So the third condition is the most important condition if you talk about CBSE examination. The last condition is the most important. Discriminant is equal to 0, then no real roots exist. Now what is discriminant? This we have already seen. Discriminant is equal to b square minus 4ac if the standard form of a quadratic equation is ax square plus bx plus c is equal to 0. So this is very important. Okay, so that's all about the formulae in quadratic equations. Now we are going to talk about the formulae in the chapter Arithmetic Progressions, which in short you call as AP as well. Okay, so suppose you've got an AP whose first term is A and common difference is d. So what is the nth term of that AP? Nth term is a plus n minus 1 into d, where n is the position of the term. And what is the nth term from end? Nth term from end. So that is equal to L minus n minus 1 into d, where what is L, guys? L is the last term of that AP. It is the last term of that AP. So that is about nth term, guys. Now you have got sum of the first n terms of this AP, which you write as Sn. So sum of the first n terms of an AP is n by 2 into 2a plus n minus 1 into d, which you also write like this: n by 2 into a plus L. So it depends, when L is given, you will use this formula. It will save your time considerably. So I hope this is clear to every student watching this. Right. Now, there is one more formula which you have to see. That is sum of the first n natural numbers. So these formula are derived using the normal formulae only to find the sum of the first n terms of an AP, but you must remember these formulae, right? So sum of the first n natural numbers is n plus 1 by 2. Now there is one more formula which you must remember: sum of the first n odd natural numbers. That is equal to what, guys? That is equal to n square. Clear? Now there is one more thing which you have to use in questions many a times. That is, nth term can be written as Sn minus Sn minus 1. So this thing is used many a times to do questions. So I hope the formulae in the chapter Arithmetic Progressions is clear to you. Now we are going to see the formulae in coordinate geometry. So suppose you have been given with 2 points whose coordinates are A x1 y1 and B x2 y2. x2 y2. And you have to find the distance between these points. The distance between these points will be AB. So AB is equal to x2 minus x1 the whole square plus y2 minus y1 the whole square, right? And square root of it. This is the formula to find the distance between 2 points, and obviously some units is there. I hope that is okay. Okay, and one more thing I would just try to say over here. This is the abscissa of this point. This is the ordinate. X coordinate is abscissa, y coordinate is ordinate. X coordinate is abscissa and y coordinate is ordinate. This you must know. Now many a times it is a corollary of this thing only which is used. Distance of a point from the origin. Distance of a point, suppose it is px comma y, and you have to find it from the origin. So distance of a point from the origin is square root of x square plus y square. If the coordinates of that point, they are x comma y. So this is the formula to find the distance of a point from the origin. It's a very simple thing which comes from the distance formula itself, because the coordinates of origin are 0 comma 0. I hope that is clear. Now, the second thing in this chapter is the section formula. It is the section formula. If suppose you have got a line segment P, the coordinates of point P is x1 comma y1 and the coordinates of the other end is x2 comma y2, and suppose R is a point lying on PQ, its coordinates are x comma y, and R is dividing PQ internally in the ratio m is to n. M is to n. Now that does not mean that PR is equal to m units and RQ is equal to n units. That does not mean that, right? Because it is the ratio of PR and RQ. I hope you understand that. Then using the section formula, the coordinates of point R can be found. It will be mx2. The pattern you have to remember, mx2 plus nx1 upon m plus n. And y will be also the same thing, the same pattern, my2. So it is my2 plus ny1 upon m plus n. Okay, now one more thing is there, you can understand it's a result of the section formula only, that is the midpoint formula, which is very helpful many a times. This is the midpoint formula. So this formula is used to find the midpoint of a line segment. Suppose you have got the coordinates of the end points of a line segment as a x1 y1 and b x2 y2, and you have to find the coordinates of the midpoint. Suppose it is c x comma y. So x over here will be x1 plus y1, sorry, it is x1 plus x2 by 2 and y will be equal to what, guys? Y is equal to y1 plus y2 by 2. So this is the midpoint formula. So these are the formulae which you have to do in this chapter. I hope it is clear to you. Now we are going to see the formulae in trigonometry. So let's start with it. Suppose you've got a triangle, a right angle triangle, and we are specifically talking about this angle over here. Suppose this is theta. Side opposite to it is the perpendicular, side adjacent to it is base, this is the hypotenuse, and obviously this is right angle, right? So over here you can say that sine theta is what, guys? Sine theta is perpendicular upon hypotenuse. What is cos theta? That is base upon hypotenuse. What is tan theta? So tan theta you can remember like this, it is sine theta by cos theta. So it will be equal to, if you take the ratio of these things, perpendicular upon hypotenuse and base upon hypotenuse, you'll get perpendicular upon base. So now you can take the reciprocals of these things. So the reciprocal of sine theta is cosec theta. So the reciprocal of perpendicular upon hypotenuse is hypotenuse upon perpendicular. Now reciprocal of cos theta is sec theta. So the reciprocal of base upon hypotenuse will be hypotenuse upon base. Now the reciprocal of tan theta is cot theta. So the reciprocal of P by B will be B by P. Now one more thing over here, although it comes from here only, that the product of sine theta and its reciprocal, that is cosec theta, will be obviously equal to 1. The product of cos theta and its reciprocal, that is sec theta, will be obviously equal to 1, right? And the product of tan theta and its reciprocal, that is cot theta, will be obviously equal to 1. I hope that is clear to every student who is watching this thing, right? Now after this, you have got trigonometric identities. So for any angle theta, sine square theta plus cos square theta is equal to 1. Now basically see, there are some conditions in the next identity, but we are not going into those things. Now over here you can use identities as per your use as well. For example, you can write sine square theta is equal to 1 minus cos square theta, and you can write cos square theta is equal to 1 minus sine square theta, depending upon the use, right? So this is your first trigonometric identity. The second trigonometric identity is 1 plus tan square theta is equal to sec square theta. Is equal to sec square theta. So over here you see again three things will come out. In place of tan square theta, you can write sec square theta minus 1. In place of 1 many a times you write sec square theta minus tan square theta. This is again used in questions, right? Now one more thing which you can take as an identity if you remember properly. See, we can use a square minus b square identity over here. So sec square theta minus tan square theta we can write like this. Sec theta plus tan theta into sec theta minus tan theta, right? And that is equal to 1. So what can I say from here? That sec theta plus tan theta is 1 by sec theta minus tan theta, and sec theta minus tan theta is 1 by sec theta plus tan theta. So they both can be used in questions. Now this was the second trigonometric identity. The third trigonometric identity which you are obviously aware of is 1 plus cot square theta is equal to cosec square theta. So over here again you can use cot square theta in the form of cosec square theta minus 1, right? Or you can write cosec square theta minus cot square theta is equal to 1. Now the same thing we can do as we did in tan and sec identity. We can use x square minus y square identity over here. So we can say this is cosec theta plus cot theta into cosec theta minus cot theta. Cosec theta minus cot theta, and that is equal to 1. So again we can say that cosec theta plus cot theta is equal to 1 by cosec theta minus cot theta, or we can say cosec theta minus cot theta is equal to 1 by cosec theta plus cot theta. So these things are used in questions many times. So that's all about formulae and identities in this chapter. Now we are going to see formulae in areas related to circles. So the very first thing is, if you have got a circle guys, and if its radius is r, so what is its area? Area of a circle is pi r square, square units obviously, right? And what is its perimeter? Area I am writing in short as A, and perimeter is circumference of the circle, I am writing in short as C, that is 2 pi r. Yes? So many a times you write it like this as well, depending upon the use. In place of r you can write diameter by 2. So this can be written as pi d square by 4 as well. It depends on the use. So I hope it is clear. Now over here as well, in place of 2r you can write diameter. So this is pi d. Many a times it will help you save time. You can do questions quickly. Now if you have got semicircle, suppose it's a closed semicircle like this. So its radius is r again. So in this case, what is the area? So area is half of the area of the circle, that is pi r square by 2 square units obviously. Now over here obviously you are not talking about its circumference, because the perimeter of a circle is its circumference. In case of a semicircle you talk about its perimeter, right? Now you see one thing, for the whole circle it is 2 pi r. This thing is 2 pi r. So half will be pi r, but over here you have to include the diameter as well. So that is 2r over here. So this is important. Now if you have got a quadrant of a circle, so these things you can do to save your time. So area of a quadrant of a circle is what guys? that will be area of a circle divided by 4 because it is 1/4 of a circle. Now what is its perimeter? If you talk about the quadrant, so you see for the whole circle the circumference was 2 pi r. So for this it will be 2 pi r by 4, but over here as well you have to include the radius, right? So 2 times of the radius. So you can say it is pi r by 2 plus 2r. I hope it is clear. Now let's talk about sector and segment. So again, if you have got a circle over here and you have got an arc whose length is L and that arc is subtending an angle theta at the center of the circle, and radius of the circle is r over here, right? It is r. So what is the length of this arc of the circle? It is theta by 360 into 2 pi r. And what is the area of this arc, guys? I'm writing A over here. Area of this sector, that is theta by 360 into pi r square, right? So this can be used in many questions. One more important thing is A is equal to LR by 2. This result is very important because many a times it will help you save time in objective questions, especially the relation between area of a sector and the length of the corresponding arc. So A is equal to LR by 2 can be used, right? Now let's talk about segment. So if you've got a circle over here, a chord of it, right? So anything, it can be A, B, C, D, you don't have to bother about it. And this chord is subtending some angle at the center of the circle. Suppose it is subtending theta over here, right? And radius of the circle is r over here. And you have to find the area of this minor segment. So area of this minor segment, just suppose I'm naming it ABC. So area of this segment ABC, area of ABC, I'm writing in short. So it is what, guys? It is area of this sector. If I write like this, AOCB, so that is theta by 360 into pi r square minus area of this triangle AOC. So basically this is a tricky thing. You have to find the area of this triangle AOC. So two formulae are there. One is r square sine theta by 2, and the other formula for the area of this triangle is r square sine theta by 2 cos theta by 2. So basically both of these formulae you have to remember. The reason being, suppose you have been given with theta is equal to 45 degrees, just suppose. So in this case, theta by 2 will be what, guys? Theta by 2 will be 45 degrees. So can you find the value 45 by 2 degrees? So can you find the value of sine 45 by 2 cos 45 by 2? That is not possible. You won't be able to find the value of sine 45 by 2 cos 45 by 2 because you haven't studied that up till grade 10, right? And suppose you don't know this formula, and suppose theta is equal to 120 degrees. Suppose theta is equal to 120 degrees. So what will you do in this case? Do you know the value of sine 120 degrees? So basically both of these formulae are important. It depends on what angle is given in the question. So that's all we needed to see about formulae in this chapter. Now we are going to see formulae in the chapter surface areas and volumes. So the very first thing over here is cuboids, right? So basically I'll make a rough figure of a cuboid for you guys. So you've got this cuboid over here. Suppose this is its length, this is its breadth, and this is its height. So 2-3 things are there. The very first thing is what is its volume? So volume of a cuboid is its length into breadth into height. Obviously in cubic units, that is understandable. I'm not writing in everything, right? Now what is its lateral surface area? You also call it area of 4 walls of a room if you are in a room, right? So that is 2 into L plus B into H. This is very important. Now what is its total surface area? TSA. So that is 2 into LB plus BH plus HL. Now there is one more thing. What is the length of the longest rod which you can put inside this cuboid? So that rod will be like this, guys. The length of the longest rod which you can put inside a cuboid. Suppose it is X. So X will be equal to square root of L square plus B square plus H square. This is the length of the longest rod which you can put inside a cuboid. So I hope it is clear everything about a cuboid. Now if you have got a cube. So basically what is a cube, guys? It is nothing but a special case of a cuboid only, in which the lengths of all the edges are equal. So basically all the formulae of cuboids are as it is applicable over here. Suppose the edge over here is A. So A and A. So what is the volume of a cube, guys? This is a cube for you, right? So what is the volume of a cube? It is A cube, cubic units, needless to say it is its volume. What is its lateral surface area? It is 4A square, because 4 square faces are there. Now what is its total surface area? 6 square faces are there. So its total surface area will be 6A square. Now what is the length of the longest rod which you can put inside this cube? So you see it will come using this thing only, right? So over here you can put x square plus x square plus x square. So that will be 3x square, square root of 3x square. So that will be square root of 3 into x. So that's all about cubes and cuboids, right? Now let's talk about cylinders. So if you have got a cylinder over here, somewhat like this. I'm sorry for my bad handwriting, guys. Okay, bad figure I need to say. So this is the radius and the height over here, right? So if suppose you are assuming that it's a closed cylinder, closed on both the sides, on the top and the bottom. So what is its volume? Volume of a cylinder is pi r square h, right? And see, it is needless to say that pi you will take 22 upon 7 until and unless it is mentioned in the question. Now what is its curved surface area? CSA. So CSA of a cylinder is 2 pi RH. What is its total surface area? In total surface area, if it is a closed cylinder, so you will take the top as well as the bottom. So total surface area will be curved surface area plus area of the top as well as the area of the bottom. So you will say pi r square plus pi r square, so 2 pi r square, right? So you can take 2 pi r as common. So total surface area will be 2 pi r into r plus h. So this is the total surface area of a cylinder. So I hope it is clear. Now after this, let's talk about cones. So if you have got a cone like this over here, this is its height, which is obviously perpendicular to the base, radius, this is height, and this is its slant height. See, whenever we talk about cones and cuboids, we talk about right circular cones and cuboids only, cones and cylinders only, because there is something called oblique cone and oblique cylinder as well, but we don't talk about that thing, right? So what is its volume, guys? So volume of a cone is 1 by 3 pi r square h, obviously cubic units. What is its curved surface area? Curved surface area of a cone is pi r l. What is its total surface area? Total surface area will be what, guys? The curved surface area plus area of the base. So that will be pi r l plus pi r square. So you can take pi r as common. So it will be pi r into l plus r. And you can use the Pythagoras theorem to find the relationship between height, radius and the slant height, which is this, guys, directly L square is equal to R square plus H square. So many a times it will be used in questions. So that's all about cone which you needed to understand. Now let's talk about spheres and hemispheres. So you've got sphere over here and hemisphere. Hemisphere means obviously half of a sphere. So obviously it is three-dimensional, guys, needless to say. So if I'm taking a sphere over here and its radius is r, right? So in a sphere, what is the volume, guys? So the volume of a sphere is 4 by 3 pi r cube, obviously cubic units. And what is its, you call it curved surface area or total surface area, because the whole surface is curved. So you'll write CSA only. So its curved surface area is 4 pi r square, square units, right? Now if you have got a hemisphere, half of a sphere, so if you have got a hemisphere over here, what is its volume, guys? Obviously its volume will be half the volume of a sphere, guys. So its volume will be 2 by 3 pi r cube. What is its curved surface area? Its curved surface area will be the half of the curved surface area of a sphere. So that is 2 pi r square. Now what is its total surface area? So basically two cases are there. Suppose you are taking a solid hemisphere in which base is there, in which base, the circular base is there, its area will be pi r square. So when it's a solid hemisphere, its total surface area will be 3 pi r square, because you are taking the base as well. So therefore I am writing it's a solid hemisphere. And if it's a hollow hemisphere, only the curved surface area will be its total surface area. So that will be 2 pi r square if it's a hollow hemisphere. Now again, don't get confused. You can also think that a hollow sphere is having inside surface as well, right? So again, see, these things, basically surface areas, whether it is curved or total, it depends on the situation as well. It is situational. Volume will every time remain the same, right? But surface area can change according to the situation. So you have to understand the situation as well. So that's all about formulae in the chapter surface areas and volumes. Now let's talk about formulae in the chapter statistics. So basically the first thing is your mean. This is your mean, right? So basically out of the three methods given in NCERT, only two methods are there in your syllabus. The first is your direct method. So the direct method to find the mean you represent by x bar, that is equal to sigma fi xi upon sigma fi, right? Where fi are the frequencies of the corresponding class intervals and xi's are the class marks of the corresponding class intervals. Now the second method to find the mean is the assumed mean method. Assumed mean method. So in the assumed mean method, how do you find the mean, guys? X bar is equal to A plus sigma fi di upon sigma fi, where A is the assumed mean method, di's are the corresponding deviations, and fi, as you already know, is the sum of sigma fi is the sum of all the frequencies. So that's all about mean. Now let's see median over here. So median will be what, guys? If I write median, that will be L plus H into n by 2 minus Cf upon f, right? Now what is this L? L is the lower limit of the median class, H is the class size, n is the sum of all frequencies, Cf is what? Cumulative frequency of the class preceding the median class, and f is the frequency of the median class. So these things you have to understand. I'll repeat once again. L is the lower limit of the median class, H is the class size, N is the sum of all the frequencies, CF is the cumulative frequency of the class preceding the median class, and F is the frequency of the median class. So that's all about mean which you need to know. Obviously you have to practice questions, needless to say. Now we can see mode over here. So mode is equal to what, guys? L plus H into so L over here is the lower limit of the modal class, H is the class size. Now this F1, F0, F2 you can understand like this. Just write the numbers in that sequence, right? Sequence is this, guys, 0, 1, 2 obviously. So you can take F0, F1, F2. Obviously the middle one is the frequency of the modal class. F0 is the frequency of the class preceding the modal class. F2 is the frequency of the class succeeding the modal class. It means the frequency of the class which is after the modal class. And F0 is the frequency of the class before the modal class. So I hope this formula is clear. Now there is one more formula which is called the empirical relationship. So this is mode is equal to 3 median minus 2 mean. So many a times this formula is used especially in objective questions. So that's all we needed to do in statistics. So in this chapter, if you talk about formulae, only one formula is there, guys. Probability of an event is number of favorable outcomes divided by total number of outcomes. Number of outcomes. And one more thing is there, guys. Probability of an event, if you take PE, it is never less than 0 and it is never greater than 1. So many a times it is also asked. So probability of an event is 0, then that event is called impossible event. And if the probability of an event is 1, that is called a sure event. So that's all about formulae, guys. Thanks for watching that. Don't forget to like, share and subscribe and press the bell icon. And don't forget to check the playlist of the Board Brahmastra series.